Okay, in the last class, we have discussed what is basically a Fourier series. Okay, so Fourier series is a mathematical tool which is used for the frequency analysis of signals. Okay, so what it means that if you pass a signal or if you apply Fourier series to a signal, what you get at the output is the spectrum of the signal. Okay, so by spectrum we simply mean that you find the various frequencies which are present in the input signal. Okay, or you can say simply that it converts a signal from time domain to frequency domain. And when you say the frequencies in the signal, the frequencies in the signal means either the complex exponentials or sinusoidal signals. So it basically decomposes a signal xt in terms of complex exponentials or in terms of sinusoids. So these two signals, in that case, they become the basis functions, or we call them as the building blocks. Okay, because any signal xt can be decomposed in the form of cos and sin omega naught t or e raised to power j omega naught t. Okay, so these two signals, they become the fundamental signals. Okay, so that is why when you start with the theory of signal and systems, we always concentrate mainly on these two signals. Okay, so we have seen that any signal xt, we say that we can write this signal in the form of a series, which is this series, which we call as Fourier series. So any signal xt which is periodic with a time period of 2 pi by omega naught, that can be decomposed in the form of a series like this, which is called Fourier series. Okay, and the question is how to find this Fourier series coefficient. Okay, because see, when the signal xt is given to it is periodic, from that signal you can simply calculate what is the time period, and once you know the time period, you can compute this parameter omega naught, which is 2 pi by t. Let us suppose, if I take a simple example, suppose I take a periodic signal like this, a square wave. Okay, and if this is 0, so this is one time period, you can say, from this to this point. Okay, or you can simply say from this to this point. Suppose it is 2, it is minus 2, it means the time period of this signal is 4. Okay, so I can simply say what is my omega naught, the fundamental frequency is 2 pi by 4, it is pi by 2. So omega naught you can compute like this. Okay, so you may have another signal like this. This is 0, this is 4, this is 8, 12, and so on. So time period for this signal is 4. Okay, again, so what is omega naught? It is again 2 pi by 4, which is pi by 2. It means both these signals, they have the same fundamental frequency. So when you decompose this signal using the Fourier series, at the output you will have one frequency omega naught, that is pi by 2. Another frequency will be 2 omega naught, then 3 omega naught, harmonics of this. Okay, and for both these signals the frequencies will be same. Where will be the difference? The differences will be in their Fourier series coefficient. For this signal, your AK will be different. For this signal, AK will be different. Okay, so the question is that how you can find AK once a signal is given to you. Okay, so we will develop a relation in which you can find ak from xt. So xt will be given to you. You have to first calculate ak from xt, and once you calculate ak, omega naught you have directly computed from the signal using 2 pi by t. You can put ak and omega naught in this equation. You can write the Fourier series. Okay, so how to find this Fourier series coefficient? What we do, we start from this equation. Xt is equal to summation of ak e raised power j omega naught kt. We multiply both sides of this equation with e raised power minus j n omega naught t first. Okay, so I can write it as summation of k from minus to plus infinity ak e raised power j omega naught kt into e raised power minus j omega naught nt. And after this multiplication, we integrate on both sides for one time period. Okay, 0 to t, or you can take from t to 2t, 2t to 3t, or in general over any one time period, because the signal is periodic. So integration for one time period will be same. Okay, so I have multiplied this equation on both sides with e raised power minus j n omega naught t and integrated for one time period. Okay, now in this right hand side, you can change this order of summation and integration, and I can modify this equation as minus to plus infinity 0 to t ak. In these two products, your e raised power j omega naught t is common, so I can take it as e raised power j omega naught t k minus n into dt. Okay, and this integration, if you see to this integration, this factor, it is simply 0 to t. I can decompose into cos and sine. It will become cos of omega naught, or I can write it as cos of k minus n omega naught t dt plus j 0 to t integral sine of k minus n omega naught t dt. Okay, and what will be this integral? See, if I take two cases, in one case when your k is equal to n, and one case when k is not equal to n. When k is equal to n, it is sine 0, which is 0. This part becomes 0, and this will become cos 0, that is 1. You will just get your dt, integration of dt. So for k is equal to n, this integration will become 0 to t dt plus 0. Okay, because cos k minus n, k is equal to n, cos 0 is 1. You will just get dt, and this sine of 0 will become 0. So this is equal to t in fact. Okay, so when k is equal to n, this entire integration, it converges to t. And if k is not equal to n, what will happen? For k not equal to n, this integration will become 0. Okay, why it is 0? Because if k is not equal to n, it means k minus n, since k and n both are integers, so if k is not equal to n, k minus n will also be an integer value. Okay, it can be 1, it can be 2, it can be 3 and 4 and so on. Okay, so k minus n, if it is suppose 2, it means you are getting here integration from 0 to t cos of 2 omega naught t into dt. Now cos of 2 omega naught t, Omega naught is the fundamental time period of the signal, which is omega naught is 2 pi by t. So the frequency of this is 2 times of the fundamental frequency. It means the time period of this signal is half. Okay, so time period of this will be t by 2 because frequency is double. Or in fact, if you can say that if omega naught is the fundamental frequency of xt, what will be the fundamental frequency of this when k is not equal to 1? It will be k minus n times omega naught. So time period will be t upon k minus n, magnitude of this. Okay, because k minus n can be negative value also, right? But if it is negative, so cos of this minus x will become cos of x. If it is sine of minus x, will become minus of sine x. Anyhow, the frequency and in the time period you have to take magnitude of k minus n. Okay, so time period becomes it is reduced by factor of k minus n. Okay, like in this case it becomes half. It means if the original signal is repeating with a time period of suppose 2, this will repeat for k is not equal to n, will repeat with a time period which is t by k minus n. Okay, so it will have multiple cycles of basically sine and cosine functions. And when you integrate over one time period, okay, now suppose t is equal to 2 is my time period, and if k minus n is equal to 2, it means in the time period of your cosine and the sine function in these equations will be 1 second. Okay, so you'll get one cos function and one sine function with a time period of 1 second. This is suppose 1. Whereas the time period of original signal xt at that was 2. Okay, so original signal can be any function. It may be like this. Sorry. It may be a square wave like this. Okay, this is the time period 2. So the original sequence is repeating with the time period of 2. But if I have taken k minus n is equal to 2, so that can be 1 k is 3 n is 1. Okay, or 1 k is 4 n is 2, where k minus n is 2. It means in this integration, the cos and the sine functions, their time period will be half. So this is the situation. It means in one cycle of the original signal, you are getting the 2 cycles of sine and cosine functions. Okay, so or otherwise in general you can say that if t is the time period of xt, for k is not equal to n, you will get k minus n cycles of sine and cosine function in one time period. So if you integrate over one time period this function, it means you are integrating k minus n cycles of sine and cosine. And for sine and cosine function, you can see that for one time period, the integration of sine is 0 because its average value is 0 plus minus. Similarly, for cos function over one time period, the integration is again 0. So if the integration of sine or cosine for one time period is 0, or one cycle is 0, it is also 0 for 2 cycles or 3 cycles or 4 cycles. Okay, so as a result, when k is not equal to n, this integration it becomes 0. It means you have a integration, then you have a summation here. So when you vary k from minus to plus infinity, so at only one point when k becomes equal to n, at that point you will have a non-zero value which is equal to t. Otherwise all other values they become 0. Okay, so this integration on the right hand side, it simply converges to an times t. when k is equal to n, at that point you will get an, and this entire equation on the right hand side will become t. For all the values it becomes 0. Okay, so you get this relation now. So integration of 0 to t e raised to power j k minus n omega naught t dt, it is equal to t when k is equal to n, 0 when k is not equal to n. Okay, so in the previous case what we have done, 0 to 2 it was xt multiplied with e raised to power minus j and omega naught t, it will become an times t. So from this equation you can calculate an, which is 1 by t integration from 0 to t xt raised to power minus j omega naught n t dt. Or you can write it in terms of k also, ak, which is integration of 1 to 0 to t xt e raised to power minus j omega naught kt dt. So this gives the equation to find the Fourier series coefficient ak from xt. Okay, so this equation is also called as analysis equation. Another equation is called as synthesis equation. So you have two equations now for Fourier series. First is xt is equal to summation of ak e raised to power j omega naught kt. This is called Fourier series. And how you find ak from xt, that is given by this equation. You can write integration from 0 to t, or you can simply write integration over t, that is integration over one time period xt e raised to power minus j omega naught kt dt. So this is your Fourier series, and these are your Fourier series coefficients. Okay, so if any signal is given to you and you are supposed to find its Fourier series, so it means you have to find simply its Fourier series coefficients. Okay, because once you calculate ak, you can put into this equation and you can see what is the Fourier series expansion of that signal. Okay, so as example, suppose you have a signal xt is equal to sine omega naught t, and you have to find its exponential Fourier series. This is called as exponential Fourier series. There is another series that is called as trigonometric Fourier series. So xt is equal to sine omega naught. If you want to find Fourier series, what you have to simply do, you have to write the signal in terms of this series. Now in this case, you are not supposed to find this integration and everything, because you can simply write it using e raised to power j omega naught t minus e raised to power minus j omega naught t upon 2j. So it is 1 by 2j e raised to power j omega naught t minus 1 by 2j e raised to power minus j omega naught t. So it is already in the form of complex exponentials. Okay, so from this you can simply say what is my a not constant, it is 0, because in this expansion there is no constant term. And what is a1? a1 is the coefficient for the fundamental frequency or first harmonic, that is omega naught t. So a naught 1 in this case is 1 by 2j, and a minus 1 is also a minus 1 in this case is minus 1 by 2j. Okay, rest of the coefficients they are 0. So a2, a3, everything that is 0. So this is the Fourier series for sine omega naught t. Similarly, you can find the Fourier series for cos omega naught t. In that case, it will become e raised to power j omega naught t plus e raised to power minus j omega naught t upon 2. So again, for this case, your a naught is 0, constant term. A1 will be 1 by 2. A minus 1 is also 1 by 2, and rest of the coefficients, they are 0. Okay. So if any signal is given in the form of sine and cosine functions, and you have to find its exponential series, you have to simply decompose in terms of exponentials, and from that you have to compare what is the constant term, that gives you a naught, then what is the coefficient with fundamental frequency omega naught, that will give you a1, and so on. Okay, so I give you a simple question to you for this. Suppose you have a signal xt is equal to 1 plus maybe sine of 2 pi t plus 1 by 2 cos of 4 pi t plus 1 by 4 cos of 8 pi t plus pi by 6. Okay, this is signal, and you have to find the exponential Fourier series for this. So you have to simply find the coefficients ak. You have to find what is a0, you have to find what is a1, what is a minus 1, then what is a2, what is a minus 2, and so on. Okay, so if you need to decompose this into exponentials, so you have to see what is the fundamental frequency omega naught, and 2 omega naught, and 3 omega naught, 4 omega naught. So the coefficient of omega naught will be a1, the coefficient of 2 omega naught will be a2, and so on. Okay, so this you have to do.